So if there is one common theme through calculus, I would say that that common theme is all about slopes. We'll talk about slope at a point, slope between 2 points, slope as we approach a point. We'll talk about slope every which way. And so that seems really easy, but it will get a little more tedious as we move through. So let's talk about some notation that you will see in calculus. Well, first of all, when we find the slope of a line between 2 points, how do we do that? Okay, that's okay though, but that is slope-intercept form of a line. But how do you find the slope itself? Find the difference in the y's, that's your rise, right? How much it rises, over the run, which is your difference in your x's. So what we use a lot of times now in calculus is a little different notation, and I feel like I may have talked about this in pre-cal, but maybe not. Sometimes we use this little symbol like this. That's a delta symbol in Greek, and what it means is difference. Have y'all seen that before? I thought I did. Tell me, we're still talking about lines here for a little bit. What does that symbol mean? Yeah, parallel. What's special about parallel lines? Same slope. They never intersect and they have the same slope. We will write so many equations of lines parallel and what is that? Perpendicular, which means what? Besides the 90-degree slopes are, yep. Negative reciprocal slopes. Flip and switch, right? Flip the fraction over, switch the sign. Everybody okay so far? Just kind of a recap. This is a little bit of an Algebra 1 recap with a little calculus-y spin on it. Given a point and a slope, how do you write the equation of a line? Okay, so y equals mx plus b is slope-intercept form, and probably not, although you can, you'll have to do some manipulation to find b. So if I have a point and a slope, I probably don't want to use that one. Point slope form. Do y'all remember point slope form of a line? M, which is your slope, times x minus x1. This is probably the one that you will use the most. You may use this sometimes. Sometimes they'll ask you to put it in slope-intercept form. Most of the time in here, we'll use point slope form. And of course, x1, y1 is just a point on that line, any point on that line, and m is the slope. Let's see. Oh, no. Kind of ironic. Here, me a bit. Can y'all do all these, or do you need me to do some examples of these? As I go through, y'all have to stop me on what y'all need me to do examples of, and I'll just kind of recap what we got. Are y'all good with finding slopes, writing equations of lines, parallel and perpendicular slopes? Okay. All right, then we'll keep going. This is that whole prereq. You will see, this is, I'm moving on to functions and their graphs here a little bit. Domain and range. Domain is the what? X. Ooh. Range, of course, being the y. You'll see sometimes in your book a new notation. Most of the time, I like you to use interval notation. Y'all remember interval notation? Yes, that's the, yes. So calculus is funny, and I don't know why they do it, but you'll get on the calculus, the AP exam, and they'll mix all these different notations around. So I just want to make sure you've been exposed to all of them if you see it. There's no special way you have to write it, but it could be a multiple choice question, and they put it in just inequality form or interval notation form or step builder notation, which I'm fixing to show you. So I just want to make sure you've been introduced. Have you done interval notation before? So this would be like if x is greater than or equal to 5, I would say then it starts at 5 and it goes on to infinity. Have you done that before? Okay. All right, so that's interval notation. So then we have what we call set builder notation. And what it does, it's basically inequality notation, but it first defines, it'll define the variable. So for x, such that the x value is between two values here. A could be anything you want. So, do I? It looks weird, it does. It just has this x in front that it defines. In interval notation, this would look like this. And then if I just used inequality notation, it would just be this. It's just they just throw that. Don't let that throw you in the front where they define the variable to start with. You'll just see it written like that, so I want to make sure that you saw that. Yeah. Say that again. Sorry. Okay. Let's make sure you got domain and range down real quick with an example, just to make sure. We'll do a nice little parent function. Y'all ready? You might need your calculator. In fact, take out your calculator. We'll look at it on the calculator. Make sure you can graph it, adjust your window, and everything else. Who? Avery, I thought you were supposed to keep him straight. He makes you so angry, doesn't he? Yes, he does anything. Like, no, yes, yeah. Like, over the summer, my parents would like go out of town, and I would like look at the graph to pick up on the range. But algebraically, how do I look at the domain here? What are the things I look for in domain that cause problems? Holes, definitely. How is a hole? How do I have a hole in a graph? What does that look like algebraically? Say it again. Denominator equal to 0 will cause a vertical asymptote. Let me show you an example of what a hole looks like. When you have something like this, and these cancel out, do you remember that? That means there's a hole at 3. Right? It messes with my continuity, and it messes with my domain. Remember that? Okay. But when the bottom equals 0, not because it cancels, so in this case, -2, I have a perplex. Remember that? And we'll get to the horizontal asymptote because our high-coded, bottom-coded is going to. Are y'all sure you remember? No? So you have factors that cancel out. Domains. Factors that cancel out cause holes. If nothing cancels, where the bottom equals 0. Again, if I'm doing too much or going too fast, y'all, I don't want y'all leaving here going, what did I get into? As I recap, because it's okay if you don't remember. You just need to let me know. Where the bottom equals 0, those are vertical asymptotes. As long as nothing cancels out. Remember all that? And if there's something that you haven't had that I go, okay. So in the case of my reciprocal function, my parent function here, and I ran off all these parent functions for you with all their stuff, I'll give those to y'all probably tomorrow, unless you want them today, if I finish in time. In the case of this reciprocal function, which is a parent function, right? Y'all remember doing that, and then we shifted it, stretched it, moved it, flipped it. What are any domain restrictions I have there, or what should I see as domain restrictions there? What can x not be? 0. Is it a whole or an asymptote? Why? The bottom to 0, nothing cancels. Does that make sense? Okay, so now graph it on your calculator. Do y equals 1 over x, and you can just do a Zoom standard if you want to. Does everybody remember how to use your calculator? It's dead. It's dead. Oh, I think I have 2 up here. Just to kind of knock off the cobwebs and refresh a little bit about calculator usage and what happens, because I'm going to give you one that's a little bit harder also. All right, 1 over x. I'm going to do a standard Zoom 6. Make sure you know what your asymptotes look like on your calculator. This one, remember these that we did, they have the vertical and the horizontal asymptotes there. X equals 0 and y equals 0. So that's good. Goes up correctly. So my domain here would be negative infinity to 0, bracket or parenthesis? Parenthesis. It does not include, and then from 0 to infinity. Range would actually be the same. Ditto. Does that make sense? Yes. Yes. Range is bottoms up. Looking at the graph, we can determine that actually if you go back, if you think about top heavy, bottom heavy, and same. I think I had that somewhere else, but we'll do it now. We'll talk about that in depth here. But your horizontal asymptotes, and this is only when you're talking about rational functions, in other words, fractions. We have top heavy. Oh, why it did that? I don't even know what that is. Bottom heavy. What do I mean by top heavy, bottom heavy, and same? What am I looking at? The exponent, the biggest exponent, top, biggest exponent, bottom. So top heavy, my exponent's bigger on the top than it is on the bottom. Do you remember what happens there? I always start with this one. You know, 1 over x, is that top heavy, bottom heavy, or same? That's bottom heavy, right? Because this has got 1, this would be actually x to the 0, right? So it's bottom heavy. And where's my asymptote? On 0. Bottom heavy always has y equals 0 as the asymptote. Top heavy has no horizontal asymptote. And the same has, Yes, it's the leading coefficient of the top divided by the leading coefficient of the bottom. So that does impact my range there. Let me give you one to try. Domain and range, see what happens. Yes. These are horizontal asymptotes. So vertical asymptotes, I'm looking at where the bottom equals 0, but the factor does not cancel out horizontal asymptotes, top heavy, bottom heavy stack. Is this too much in one day? Are your heads spinning? Yes. I hear no and yes. A little bit. Okay. So we might stop after domain and range, give you some practice with it maybe. Well, maybe after, we'll finish 1, 2. We'll do 1, 1, and 1, 2. Do a little bit of. It's too cold in here, Fisher? Oh, Khalil, it's not even gone. In the domain and range. That's a fourth root, yep. Domain and range. So you can look at it graphically and then we'll confirm some of it algebraically. Don't you see what happens? Hit 4, max 5. With this radical, when you see the radical on the bottom, that's the other thing, remember, that causes me some domain restrictions, because any even root has to remain what? Positive. Thank you, Khalil. It has to remain positive, because I'm not graphing imaginary numbers, right? If I have the square root of a negative number or the fourth root of a negative number, I end up in imaginary land, and I'm graphing real numbers. So 1, I need to worry about where the bottom's going to be 0. If it's a 0. 2, I need to worry about keeping it positive. I need to worry about keeping it between whatever values will keep it positive. So that's why you see when you're graphing, so it looks like a little piece of a circle, it's got to stay between those two values in order to stay positive. So what'd you find for the domain here? What you think? Tell me what you think it is. -3 to 3, inclusive, exclusive. Inclusive, so can it be 3? Why can, okay, Abby said no, why? If you plug a 3 in here, what happens? 9 minus 9 is 0, and I'm undefined. So remember, I got to look at positive and no zeros on the bottom. So it's exclusive. Does that make sense? So what they did, I should have showed you the graph. Here's the graph, right? So algebraically, I would do 2 things. I'd set the bottom to 0, see where it's 0. And I'd need to leave that out, in which case it's 3 and -3. And the other thing I would do is make sure it stays positive, and that's why I'm between. My, oh, that. Oh, I hit trace. If you hit trace, it won't give you an exact, but that's what I wanted to show you also. See how it goes? It's like 2.9787. You go past, it's not there. Another little trick, if you don't know if it's inclusive or exclusive, if you go second graph and go into your table, and I put the 3 in there, it's going to tell me that's an error because it can't actually be 3. Same with -3. But I could be 2.9999999. Now, as I'm at 2.9999999, what do you notice is happening? It got really, really big, right? It doesn't look like that on my graph, though. Does your graph look like that? It looks like it stops. Does yours go on forever, or does yours stop? It stops. So we have what we call a calculator failure here, which means our calculator, so you have to be aware of those kind of things, okay? So in this table, if I kept going back, the more 9s you put in here, oh, that was too many. It gets really big really fast. So what's that graph? What does that tell you that graph is doing? That's right. That's right. And in fact, that looks like what there? A vertical asymptote. Looks like I have a vertical asymptote at -3 and 3, which would make sense, right? Because if I set this bottom equal to 0, x is going to be positive or -3 when you solve it. Fourth root, subtract the 9, negate square root. So that is impacting my domain, but it's also impacting my range because it's hugging that vertical asymptote as it goes up. So what do you think my range is on this graph? Anybody? The range. Looks like the lowest it goes. And I could remember how we calculate a minimum? I could calculate a minimum value, see how low it actually goes. What's yours? 0.577. So I'd say the range on this one, up to. I went 4 places. 3 is the minimum on AP. I just went into the calculator there and I did second trace and found the minimum. Remember how we did that? And then we did left down, right down. For the X or the Y? Look at Y because we're ranged. That's okay. That's okay. I did the same thing whenever I looked at it the first time. I was like, yeah. Domain and range has always been a struggle, right? Domain and range is hard. What you think? Stop or keep going? The range, not yet. We will define that by calculus on how our asymptotes are defined calculusy, but not quite yet. You want to do some practice with domain range? Sure. Let's see what I got. Let's do. We're still ahead of last year because I had to do. Let's do. Oh, you don't have the page. I'm gonna write the page and I'm gonna post it up here. Page 19. type in that in the item. I'm going to put it up here, and then I'll take a picture and upload it.